Well, the privilege is all mine to be here again for the second of my second edition of Big Data Spain, which has been great. And this year, actually, I'm not going to talk about a specific tool. I'm going to kind of lead you about a future of what is a database and what sort of technologies actually we see today in data processing. And well, let's start with this question that popped into my mind. So, are we actually reaching a sort of a data science singularity? So, I don't know if you've heard of a singularity. Is this idea that basically in machines will become at a certain point more intelligent than human beings and take over the world and keep us in the world as pets. Which is an interesting idea because, I mean, we still have a role in the future. But then again, let's see what happened in the last 50 years. So we started 50 years ago looking at UFOs and objects flying in the sky which were unidentified. And today we have identified objects that fly in the sky and they look also pretty amazing, like this unmanned aerial vehicle. So basically, the same thing is happening with computers and with technology that helps us to understand data. This is our, let's say, Star Trek slide with Leonard Nimoy in the role of Spock in the Enterprise, interacting with a computer. And this particular episode is the episode where in 1968, where it was called the ultimate computer. And look at those fantastic beams of lights which are generated by this machine with superhuman intelligence. That, of course, reminds me some logos and sort of concept, UI concept that we see today developed by a number of companies. And of course, there is a lot to it in terms of inspiration and the sci-fi part of it and the UI part of it. But the question of today is, what about data science? What about science? So what are actually the components and the technologies that are making all this possible, let alone, let's say, the way the data is visualized or the inspiration coming from sci-fi? So I'm going to drive you to this sort of tour of technologies and tools which are at the foundation of healthy and well-developed data science, machine learning, and artificial intelligence, staying a bit away from let's say, simplistic hype like the ultimate computer of Mr. Spock. But in a way, there is some fundamental truth in it, because we talk today is, what we see today is increasingly interaction between man and machine. And we could definitely say that man and machine are becoming sort of integrated cognitive systems. There is nothing scary about that. It's the fact that a machine is a tool and that we use the machine as a tool to understand data. And we do that more and more often. And as such, we learn from what the machine provides us in terms of understanding of the data, and we feedback model that are again elaborated by machines. So just to jump back in time, this guy here is Hans Christian Ørsted, coined a term which got very much in vogue lately. So today we talk about data scientist, but this guy actually coined the term scientist. It was in the year 1811, so basically it's about 100 years that we have the concept of a scientist. And what is a scientist? A scientist is a person that, according to a certain scientific method, would look into the world, make some observations, generate some hypotheses, deduct some conclusion out of it, maybe abstract some formulas or some schemes out of these observations, and perform some experiment and then report it to the community and explain why the world is actually working the way it is working. And this process actually, I would state today that what we do with machine is the same process, but that in each and every part of this process, we have machines and computing as part of the scientific method. We cannot observe, make hypotheses, create experiments and deductions without machines anymore. So we are, in fact, kind of so much connected to our tools that it's fundamental that we understand how data analytics works today. And my point here is that innovation in data analytics is mainly driven by three components. So today we talk about cloud, community, and AI and machine learning. So cloud. The cloud is actually interesting because for the first time in time, we can, in this open source revolution, according to the words of Sam Ramji, which is the CEO of Cloud Foundry, we can actually have sufficient open source technology that we can stack open source layer from the ground up, starting from infrastructure up to analytics, and build basically an entire ecosystem based on open source technologies. So if you look at such a stack, it's incredible how we went from bare machines to virtual resources and images, and then inserted that weird layer that today we call containers that actually enables us to create smaller packages of bundles of resources that can coexist in the same physical or virtual machine. And going up to these layers called the dPaaS, that today we differentiate in two ways: the infrastructure PaaS and the data platform as a service. We see things coming up like data stores, data engines, and we can all plug and use all these components to create amazing experiences and data processing pipelines. And the latest arrival on this stack is data analytics as a service. So we're seeing many companies today developing models and tools and systems to compute, train, score data, to provide ready-made algorithms for the understanding of speech, language, to analyze vision, pictures, images, videos, but also generally to understand data. Because data, in fact, with all these possible let's say, components in it, the classification, the clustering, the anomaly detection, is definitely something that is now ready to be exposed as a service. So data analytics as a service is the upper top layer today in a quite deep stack of, let's say, cloud technologies. Another thing, very interesting, so these days we are not bound to just a single cluster. Clusters generated on top of cloud infrastructure, they can be created by a team, they can be used to load data, compute some very complex operations, and then store the operation and be destroyed and be freed for others to create other clusters. So technologies like Spark, like Flink, like Dataflow that we've seen today are actually nothing else than what I call it ephemeral computing. You take a cluster just because you need to solve a particular problem, but you're not bound to these resources. So now computing becomes a disposable component or disposable step in your data processing. So, in fact, if you look at ephemeral versus permanent, it's actually an interesting thing which is happening today in cloud computing. Some of those resources will be long-lived and permanent. So, for instance, if you want to store your data, it's going to be there for maybe for a longer period, years or more, and you want to use it maybe for some production level sort of continuity. But you have also a lot of data exploration and a lot of, let's say, short-lived analytics. And those comes also with pros and cons, because the ephemeral cluster allows you to have simple access management, because you have created for one purpose and one purpose only, so you can actually keep the access on that system actually very contained. On the other side, you see that permanent, let's say, platform as a service components like a file system are actually now coordinated. They have better security, better access management, and probably we'll see more of both in the future. There is a lot of talk being said about GPUs and distributed computing these days. So if you look at this graph, it's actually kind of interesting. We started with that machine, which was doing just one thing, one operating system, running a single-threaded code. And now we spawn in two different directions. We scale up, and then we have basically more computing resources on a single machine, and we scale out. So we start talking about distributed computing. Now, what's happening now, it's fascinating that these two actually are converging into the next layer of, or the next level of distributed computing, where we actually have scaled up and out with clusters, which includes very expensive resources as GPUs, and can also be instantiated on a number of machines. Spark TensorFlames is one of those examples. It's pretty new, it's quite modern. And GPU support is coming for Kubernetes and Mesos and Spark. And it's pretty quite, let's say, exciting times ahead on that front. A community is fundamental, because, in fact, what you're seeing today, and that's also the result of the panel that we just saw an hour ago, is that without that loop of develop, use, and share, we actually cannot keep up the energy in innovating. So innovation today only happens if you actually have these three components. People which are opinionated and motivated and enthusiastic about some technology, that use it, that actually take the time to report bugs and issues and possible, let's say, extension for the tool and new features, share those ideas, and developers which are actually contributing to those projects and massively improving it. So with that respect, I would say that today sharing is more than caring, is actually improving the speed of innovation today. And on that front, I would say that there are two, or actually three main ideas that pop up in my mind. One is related to the research. If you know, archive.org is a website that hosts scientific papers. And innovation is happening there, because now you can share your collection of scientific paper and understand which idea is revolutionizing a certain domain. So, for instance, like convolutional neural networks and so forth. On the other side, two great projects, Jupyter, and also that innovation around the concept of social coding, promoted by companies like GitHub and Git itself, as an idea of sharing code, but also sharing text. So there are actually people on GitHub that do not program, but actually share code, share the text and the curated links on GitHub. And Jupyter Notebooks as basically documented running code on data science, on algorithm, and so forth. So that brings me to artificial intelligence and machine learning. Google has been a great supporter of this sharing economy, in particular, since they have open-sourced TensorFlow, but not only TensorFlow, but a lot of models which are based on TensorFlow. This is one of the latest results which has been published by Google. Is probably the best NLP parser, which performs with a 95% accuracy in basically understanding the grammar of about 40 different languages. So it's not just about English, American English, but it's about 40 different languages which are supported by this tool. Now, the entire model is centered around deep convolutional networks, and it's available on GitHub. The link is right up there. This model is based, in fact, on the concept of embeddings. So the fact that words surrounded by some context would allow you to understand which part of the speech, which part of the sentence corresponds to a particular term in the word, in the sentence itself. And in fact, is great because it kind of closed the loop between the traditional, let's say, NLP, natural language processing, which was initiated by guys like Chomsky in the past, and now they got a completely reinvented and brought into the domain of deep learning, going from discrete to actually continuous spaces, the so-called embedding, and bringing together this fantastic result. So talking again about embeddings and the word2vec, so this idea that you can take a word, since we are in Spain, imagine a word like chorizo, and then you would actually describe that as a sort of, let's say, collection of, or a cloud of a vector of variables, and then map these variables in a two-dimensional space, and all of a sudden, words, they start to cluster and be organized in groups. So, for instance, all the words related to, let's say, the Spanish dishes would be there in a particular cluster, as, for instance, words related to architecture. And this is actually a good example of how you could take the entire Wikipedia collection of pages and create a sort of emerging pattern of structures which are actually self-organizing. And there are a couple of papers here which are reported which indeed go in that direction. Another great result, lip reading. So a new algorithm is being provided, again with deep learning, and this one is a hybrid one, takes actually audio and video, and combines audio and video cues to actually provide you a text. And although the data set is still quite small, this is using the so-called grid corpus, which is more of an artificial data set. But on this set, actually, this idea is already providing 93% accuracy, while, let's say, professional people which are in this domain, which are able to read, to do lip reading, actually they only can perform 40% on this data set. So imagine the benefit of bringing this to communities or for the healthcare or for the and so forth. Again, another fantastic result, which is just about a year old. It's called Ask Me Anything. So it's a neural network which is deep enough and complex enough that actually can translate a question into some form of understanding of pictures, of text, of documents. So you could actually provide an image like a bus in a tree and ask what is the main color of the bus, and the network will actually focus, will present a specific attention, that's the light gray part of the picture, and actually come with an answer, so saying blue. So you see there is actually an incredible result doing semantic analysis from your question, create an embedding which brings back the information of the picture, focusing the attention on part of the picture and translating that back in actual text, English text. So dynamic memory network for natural language processing, an incredible idea that has been developed by one of the rising stars of machine learning and neural networks of these days. This guy is called Richard Socher, and is based on the idea that neural networks are now becoming extremely sophisticated and hierarchical models. In particular, this one is based on the so-called bidirectional LSTMs. So these are networks that are at the same time capable of taking the wide context and the detailed information, and by multiple passes actually arriving to this very detailed conclusion and the Q&A performances. So in fact, that's fantastic, because we are clearly not that good at interpreting raw data. And that is actually one thing that if you can understand how much raw data we are getting these days, and how much machines, and in particular this sort of algorithms, can help us in all sorts of domains, from healthcare to security. So we talked about security. This is actually a machine-organized security pattern, which is looking at how data is being transferred between machines in a network. So this is actually fascinating, because things like TDA, so topological data analysis, and dimensionality reduction are now actually becoming feasible on these sort of systems. So in fact, this is becoming so interesting and is so profoundly transforming the way we look at data analytics, that guys like Abhishek Thakur is a Kaggle grandmaster, actually came up with a blog post saying, wait a second, but if we have data science and we have algorithms and machine learning that actually understand and can learn things, why not actually learn about how to build machine learning? And therefore, there is an entire new branch of research and in the area of how can we streamline machine learning so that actually we don't need to go through those repetitive steps. How can we actually have a sort of a recipe for recipes? Like, we take the raw data, we do some data munging, we extract useful information, we provide some feature engineering, and then we do some sort of form of classification or regression on these data plus labels. So in fact, this was presented as a challenge, and the challenge goes under the name of AutoML challenge, and a number of results have been produced, which are actually astonishing. So machines that and systems which, by means of either Bayesian sort of learning processes, or even a more recent one produced by the team of the Freitas in England, are actually able to select the specific steps in terms of classification, pre-processing, and so forth, and actually brew for you the right data pipeline to understand your data. Isn't that fantastic, actually, that we are at this stage that we can say that indeed human plus artificial intelligence can be combined to solve these sort of problems. So, in fact, that's where I want to go with this presentation. As humans, we have a number of cognitive biases. There is an entire page which is actually dedicated to that. And if you want to summarize it in 4 different categories, they actually go into too much information, that's a table full with numbers, not enough meaning, so basically insufficient data to process your analysis, need to act fast, so not enough time to actually think and reason about it, and the amount of memory that we have. These all four are due to the fact that as indeed sophisticated we are in our cognitive processes, in fact, we also have limits. And what would be actually the best solution if not actually take a machine that could complement us on those points? As a matter of fact, the machine is also not perfect. Because if you look at all the AI today, there's some fundamental problems with it. And they still need a lot of work and a lot of research to be done in order to improve it. The model generation, so which model is emerging from those neural networks, is still very low level. So that the neural network will not come to you and say, oh, this is the formula for gravity. We are not there yet. So there are no neural networks today that actually can produce mathematics as an output, or physics, or for instance, all sorts of. We see some attempts with poetry, so we saw a few things of generating some nice plots, but that's a different thing than being part on generating formulas, for instance, for nuclear physics and so forth. Explaining why a certain result was produced. AI is still not good at it, as well as working in a fully unsupervised way, or actually moving in the direction of planning. The fact that it's not good at it, it means that it might be good at it tomorrow. So as indeed this sort of, let's say, threshold or boundaries of what is possible with machine is actually a continuously moving target. Today we say, okay, artificial intelligence is not that great because it cannot explain itself. Maybe that will change in the next years. But in the meantime, the combination of those two elements, so human cognitive aspects and machine intelligence, are very much complementary. So, in fact, I would like to make here a quotation from Minsky, which has been is done fantastic work on cognitive sciences. And we now have reached a point where we kind of understand the basic processes of mind, and we can emulate or replicate some of those processes. And we still don't understand how our high cognitive function can actually be produced or emulated or simulated. So Misk used to say that we actually have a very thorough understanding of simple things, but not enough understanding of things that work very well, like, for instance, one vision. Now, who knows, maybe by operating in this domain of man and machine cognitive processes, we might actually arrive to the point where actually these two elements are equally well understood. So, in fact, what I would like to say is that if you have a data system, you can actually you can wear the AI and ML lenses and use it as a tool to understand the data. So, in fact, the new era of intelligent machine is actually there for two reasons, in my opinion. Boost the understanding of data and focus on a higher level of analysis. Because there is much more that you can do if we can free ourselves from those, let's say, tasks which now can be delegated to machines. So, if there is, let's say, one slide that kind of summarizes this entire talk, is actually this one. And this entire presentation has been nothing else than building towards this slide. The database is actually not what we think the database is. Just like the T model is not what we think today of what a car is, right? So I want you, for a moment, to forget about what you think that a database is and concentrate on what the database could be. So a database is an organized collection of data. And if you look at it, and if you actually squint the eyes and you look at this diagram of increasingly, let's say, advanced cognitive layers, as we move on, let's say, higher from SQL to machine learning to AI, and as we extend the way we operate to these data systems, starting from SQL to Python, Scala, R, so to programmatic analytics, and we move up to natural language processing, and maybe, why not even speech. Actually, we are in a way describing a new database, but this database would be actually comparable to a very modern car to a person coming from the beginning of the 19th century. So, long live the database, and I'm very excited about it because I think that if you look at it in this new perspective, although I've not been talking about any specific technology here, but I think that the database is never going to be the same, and probably you're going to see that very, very soon. With that, I would like to thank you and wish you well for your next projects. Thank you very much.
Thank you, Natalino. Questions, please? So I would like to ask you, in this last slide, where there is like a gradient of maybe sophistication or, that one. How do you see these layers? Are they going to merge? Are they going to be atomized, or are they going to be clustered? Like, say, for instance, in clusters you can build an entity with all these 4 layers now in like 10 seconds, basically. You start a cluster.
Yeah, I understand your question. So basically, how far are we from actually creating a system which will have all those layers and something that you can instantiate in your bank or in your medical facility and operate on the data?
Yes.
I think that if you look at the latest stacks, and here I'm talking about, for instance, take the picture of Databricks talking about the Spark stack. Have a look at the stack of IBM or Amazon or all these companies. They actually are describing this. However, they don't go as far as saying that this is a monolithic system, because you can interact at different level. But my point is that, in fact, we do have already the collection of components to create this today. So, in fact, I would be very much interested in talking to you guys and discuss ideas how we can actually take this collection of systems and create the ultimate database, or let's say the database of tomorrow.
Yeah, I was very intrigued. Earlier this month, I read this paper. Well, it was a blog post, actually, about TensorFlow on an Android device, trained from a small sample of pictures of birds. And actually, you can have it on your mobile phone, and you can classify very precisely, with an accuracy of 85% plus, any picture that was presented to the script. So it was pretty impressive. I think we are moving in that direction for many other instances, yes?
Absolutely.
Very good. So if there is any other question, with this, we thank you very much. Natalino.
Thank you, Ruben.
Cheers.
Thank you, everybody.